All right, let's talk about a VMware feature that is an absolute lifesaver for anyone managing a virtual environment. It's called Enhanced vMotion Compatibility, or EVC. And believe me, if you've ever felt that pain of a server upgrade going sideways, you're going to want to stick around for this. So let's just jump right into the big question, right? You've got this shiny, powerful new server you're super excited about, and you've got your older workhorse servers that are still getting the job done. So why, when you try to get them to play nicely in the same cluster, does everything seem to fall apart? It's a super common frustration, and there's actually a really interesting reason behind it.
And yeah, that reason is what brings us to what I like to call the CPU upgrade headache. It's that moment when all the excitement of new hardware smacks right into the wall of operational reality.
I mean, picture this. The new server is racked, it's powered on, you've added it to your cluster, everything's looking good. You're ready to start moving your virtual machines over with vMotion. You know, the whole seamless, zero downtime dream. But then, you click migrate and bam! Failure. Your VMs are just stuck on the old hardware. What just happened?
And this right here is the heart of the problem. Your brand new CPU, it's got all the latest and greatest instruction sets. Let's call them A, B, C, and this cool new one, D. But your older CPU? It only speaks A, B, and C. So if a virtual machine running on that new server starts using that special D instruction, there is no way it can be live migrated to an older server that has no idea what D is. It's like trying to move to a country where no one speaks your language. That incompatibility is exactly why vMotion fails. So, how do we fix this? How do we get our old and new hardware to stop fighting? Well, this is where VMware EVC steps in to play the hero. EVC, or Enhanced vMotion Compatibility, is a feature you just switch on at the cluster level, and its whole job, its entire reason for being, is to create a standard, consistent set of CPU features that every single host in that cluster agrees to use. It was literally designed to prevent the exact vMotion failure we were just talking about. You know, the absolute easiest way to think about EVC is as a universal translator. It listens to all the different dialects that your different CPU generations are speaking, and it creates one single common language that all of your virtual machines can understand. That way, no VM ever gets confused or trapped just because it happened to move to a different host. Now, it might sound like some kind of complex voodoo, but the way EVC works is actually incredibly elegant. So let's pull back the curtain and see how it pulls off this magic. It's really just 3 simple steps. First, you, the admin, pick a baseline. This is basically you choosing a CPU generation that everyone can agree on, the common ground for the entire cluster. Second, EVC does its thing and normalizes all the features. It cleverly masks or hides any of those fancy new instructions on your newer CPUs that don't exist in the baseline. So that D feature from our example, gone. The VMs won't even know it's there. And the result? Perfect consistency. Every single VM sees the exact same CPU instruction set, no matter what physical piece of tin it's running on. And this quote just nails it. The goal is dead simple. Make sure the VMs see the same thing everywhere. It's all about giving them the freedom to move anywhere they need to within the cluster, no questions asked. So we know what EVC is, we know how it works, but now for the most important part. What's in it for you? What are the big wins? Why is turning on EVC such a game changer? Okay, the benefits here are huge. For starters, upgrades get so much simpler. You can roll in new hardware and live migrate your workloads without ever thinking about a maintenance window. That, of course, leads to that seamless mobility that's so critical for a modern data center. EVC also just reduces complexity. It handles the CPU compatibility stuff for you, which is one less thing you have to worry about. And finally, it just makes scaling and hardware refreshes easier, letting you expand your cluster with the latest tech without causing any disruption. But honestly, the most important benefit can be summed up with this number: 0. That's the number that matters. With EVC enabled, you can achieve 0 downtime during your hardware upgrades and migrations. And for any business, that is a massive, massive win. Now, like any powerful bit of tech, EVC does have a few ground rules you have to follow to make sure everything works perfectly. Don't worry, they're super straightforward, but they are non-negotiable. First thing, you can't mix and match your CPU vendors. The cluster has to be either all Intel or all AMD. Simple as that. Second, you have to have hardware virtualization enabled in the BIOS. That's Intel VTX or AMD V. I mean, this is the core tech that makes virtualization possible in the first place, so it should be on anyway. And third, no execute protection, also called the NX or XD bit, needs to be enabled. This is a basic security feature that helps stop certain types of attacks. Again, these are all standard settings for a virtual environment, but it's always smart to double check. Oh, and a quick pro tip for those of you running more modern versions of vSphere, since version 6.7, there's also a feature called PerVM EVC. This gives you even more fine-grained control, letting you set an EVC baseline on a specific VM itself. This is amazing if you need to move that VM between different clusters, or even to a totally different data center, because its compatibility level just follows it wherever it goes. So we'll leave you with this thought. We live in a world where CPU technology is just advancing at a dizzying pace. And in that world, EVC makes this really powerful argument for standardization, right? It says, let's temporarily give up the absolute bleeding-edge features in exchange for rock-solid operational stability and total flexibility. So the big question is that a trade-off worth making for a truly agile and resilient future?